Just to introduce myself, my name is Naveen. I'm a professor in civil engineering department, and I'm also affiliated with the Future City initiative that civil engineering department has been taking care of. And my just to give a brief background, I did my bachelor's in India at IIT Madras. I did my master's and PhD at UT Austin, and before coming to UCF, I was an assistant professor at McGill University, and I came to UCF in 2014. I've been associate professor for 6 years, and I just became a full professor this year. In terms of my achievements, I am particularly I work very closely with my graduate students, and that's what drives me to pursue my career as an academic. I've been able to graduate 8 PhD students as a sole advisor and 3 PhD students as a co-advisor. And I'm particularly proud of where my former PhD students are right now. One of them is an assistant professor. 2 of them are in research positions at different universities in different countries now. Also, we've received several paper awards, mainly with the students being the lead authors, and that's something I'm particularly proud of. In addition to research, I'm also very actively involved in teaching activities. At UCF, I introduced two new courses, one at a graduate level and one at the undergraduate level, providing details in my research topic, which is data analytics with a microbehavior twist. In terms of other projects I'm involved in, I was part of the committee that prepared the proposal for the MS program in travel technology and analytics program, and I'm very actively involved with the program. In fact, I'll be serving as the program director for that program that is being launched in fall 2020. So we are expecting students to start in the fall. In terms of my research motivation, my main interest is driven by my interest in quantitative approaches. So econometric models, optimization, and microsimulation techniques. These are the primary drivers of what I do. Any research that I do can be geared into one of these broad topics. In this talk, I'm focusing on 2 topics that are particularly relevant for collaborations. Again, we, as everybody has mentioned before, UCF has a very strong transportation team, and the transportation faculty at UCF work together very closely. And we're building a, in fact, we're ranked in the top 5 in the world in terms of the transportation teams in the transportation division. So the main focus of this talk is we all talk very well among ourselves. So I'm trying to broaden the scope of research that I do to other fields. So my focus is purely on collaboration in this talk, and I'll present on research topics that lead themselves to collaboration. The first topic of interest that I'm focusing on is application of econometric and behavior-oriented models. So in the last presentation, Angie presented a lot of machine learning work and deep learning work going towards improving prediction accuracy. There's nothing, I have nothing against that, but what I am trying to focus on is understanding the causal relationships and behavior aspects of research. So machine learning works very well, particularly in prediction, but the causal inference and how factors affect the choice processes are not fully understood. So my research is focused on that component. So I use classical econometrics and microeconomic theory-based approaches so that we can understand what are the factors that are influencing the choice processes or the decision processes, and how do we modify behavior. So understanding the causal relationships allows us to encourage or nudge people into doing things that are good for the economy, good for the environment and the society. So for example, if we want to consider electric vehicle adoption as a good for the sustainability of the society, we need to understand what are the factors. How important is price? How important is the range of the electric vehicle in making that decision? So these are factors that need to be evaluated, and we do not have observed data. So to run machine learning models, you need data. That data is not available. So we might have to devise experiments to understand those factors, and those experimental design will require us to understand the microeconomic theory and behavior to incorporate that. So that is one of the main focus of my first research thrust. Also, in some of the contexts that we use, data is limited. We don't have GBs and terabytes of data. Again, when that is there, machine learning and deep learning methods work very well. But when the data is limited, there are alternative approaches that do as well without reducing the causal inferences that we can make. And also, I think I really liked what Yanji mentioned in one of the points. I am also very interested in understanding, can we combine these behavioral models with the machine learning framework so that we don't not only improve prediction, but also improve causal inference. So how can we come up with something where we can do both, where we improve causality or understand causality and improve prediction capability of these models? So that would be something of interest to me. And then the second topic of interest for me is, how do we use what we do in our research group in the transportation area to build frameworks for system of system models? So for example, smart cities and connected environments are a big thing right now, and a major component of this is transportation. So anything you do to predict how urban systems evolve with smart and connected technology will have to capture transportation in a very rich detail and in an accurate fashion. That is where I think my research team can contribute, where we have been working on focusing on how transportation systems evolve, how people behave within the transportation system. And I'm interested in connecting this to any urban system level model. So this will be a very important module that can either provide inputs and outputs or interact with these modules to provide realistic predictions of the overall urban system. We are particularly interested in looking at connected vehicles, autonomous vehicles, shared vehicle systems. We've been doing a lot of work. I'll present a little bit on some of the work that we're doing in terms of the shared vehicle systems. So with these two broad thrusts, I'll focus on the three research themes that I want to talk about. The first one is the advanced data analysis. Again, traditional approaches to different machine learning models focus on a particular class of models, either continuous variables or logistic regression with 2 or 3 alternatives. In my research, I'm interested in looking at non-traditional models, variables, where you can have potentially hundreds of alternatives for each choice. Coming up with efficient approaches for estimation for that is very important, and several application areas exist. So if you're looking at energy demand and consumption patterns, that's something that's going to change with electric vehicle adoption. Then there's also interest in understanding how connected autonomous vehicles will be purchased by individuals and households. That is a dimension of interest, and transportation safety is another dimension. So what we do in our research group here is we develop models to understand different kinds of variables, not just continuous variables, not just discrete variables. We are looking at ordered variables, count variables, and even proportion variables. So the different kinds of data presents different kinds of challenges. And we also focus on looking at multiple variables in a single framework. So in machine learning models or deep learning methods, a single dependent variable is usually analyzed. Again, I'm not saying that they cannot do multiple, but what we do is we come up with unified frameworks that allow interaction across these different variables, that allows for more factors to be considered, and also recognizes that these choices are not made in independent nature. They're all, I work and decide on what car to buy, where to live. These are choices I make together. So these can be considered when you develop a unified framework. And again, this has been work that I've been doing since the start of my PhD. So we've developed several frameworks using Coupler models, using generalized order response models, grouped order systems, and fractional split models. Some of these are actually been developed in my research group and have been used by different researchers across the world. Again, we have a lot of publications in this area, and a lot of funding that I've received has been to support some of this work from different agencies, whether it was in Canada and also in the US. The second topic of interest, as I mentioned, is energy patterns. Right now in my research group, we are working on, a student is working on a PhD dissertation where we are looking at how can we come up with energy use predictions. So the reason I'm particularly interested in this area is because transportation energy plays a big role in energy consumption. And now with the advent of electric vehicles, if everybody owns an electric vehicle, or a large proportion of households own an electric vehicle, the consumption demand in oil will shift to our household units where we are charging our cars, or business units where we are charging our cars. So that would alter how the demand profile that exists currently in electric grid systems. So my interest prominently is, I know there are a lot of people working on electric grid and other areas. My interest is how can we prepare for this transition when transportation vehicles change slowly in the beginning and suddenly in the 5 or 6 years down the line from fuel dependent or fossil oil fuel dependent to electric vehicles. So that is my main area of interest. So for understanding that, we are developing benchmark models to predict current usages, so that once we have the current usages, we can start developing a simulator where we change the proportion of vehicles that are currently fossil fuel based to electric fuel based, and the corresponding impact on the spatio-temporal patterns of energy usage in the grid and in urban regions. So these are different modules that we are building. Again, I'm running out of time, so so these are proposals that are under preparation. We submitted something to the Department of Energy, and we're working on other proposals. And this is something I'm very interested in collaborating with different faculty in engineering and different centers that we have on energy. The last topic that I'll quickly focus on is the urban systems models. As I mentioned, urban systems are a complex system with substantial interactions across different modules. My area of research is in the transportation, and I'm interested in looking at how these interact with different parts of the urban system. So we worked a little bit on health, for example, looking at how walking and biking in the transportation system can result in health benefits, or lack of walking and biking can result in bad health indicators. We also looked at air pollution impacts of transportation demand. So these are different dimensions that we are working on, and these have direct implications for property values, vulnerable populations, and all of these things. Our objective is to build a simulator that can predict these embedded with behavior. So all of these individual components of the simulator will have embedded models that track human behavior. Some examples of research studies that we're doing, we did some work on rideshare systems in New York, where we are looking at how Uber and Lyft have revolutionized industry by taking a large share of taxi business there, but also increasing the overall demand for ride sharing systems. So we just did a paper on this, and we also did a lot of work in understanding bike share systems. Our interest is understanding where people take their bike and where are they dropping it off. So in New York City, once you take a bike, potentially you could go to any station within 5 to 10 miles. So the choice of bike destination is quite complex, and we've developed some mathematical models to understand that. In terms of future plans, in the short term, energy pattern modeling is something that I'll work on, and in the long term, I want to build collaborations for discussions with different engineering colleagues, so that we can actually go after some large NSF ERC engineering research center type of grants. That's something that would be prestigious and competitive. Also, in terms of teaching activities, I will be actively working in the Masters in Travel Technology Analytics program, so that we increase enrollment and also build that program which has extensive industry collaborations. So that would be another topic that in terms of teaching field that I'll be working on. Again, these are the list of my various students and faculty that I work on with closely at UCF and other universities outside UCF. And at this point, I'm open to take any questions.